So here we are, sharing secrets of the soil with me, your host, Regenerative. Hello, soil lovers, and welcome to another episode of Secrets of the Soil. I'm your host, Regenerative, and today we're going to go really deep. Well, actually, we're going to stay on the surface. We're going to talk about cover cropping and why it's important to protect your soil with Christos. Welcome to the show.
Thanks, Ray. It's always a pleasure to be speaking on your program about a really important message.
Excellent.
Yeah.
Awesome. And for our soil lovers, if you want to know more about Christos, then you have to go and check out episode 8, where we have also had a chat about a little bit about who you are. So today we're going to go right into the topic. Why do you find cover cropping such an important part to talk about when it comes to soil life and health?
Look, after 18 years of immersing myself in nature-based solutions to mitigate against global warming or mitigate global warming, I realized that nature is so complex. These interconnectivity that nature expresses, that our science is in some ways left behind because we tend to use reductionism, simplifying things and so on to comprehend. We break things apart, but we don't see how it's all put together again. So when communicating, I thought to myself, what is the one thing, the kind of mantra, the modus operandi, the major focus that will make the biggest difference in kind of one statement? And it's as follows. Cover crops has got climate change covered, in that we need to keep all of the ground covered all of the time. And I mean all of the ground covered all the time, except, of course, deserts. We learn most when we kind of step back and empty ourselves of our preconceptions and actually observe nature and try to mimic her wisdom, economy, majesty, beauty, mystery, without trying to romanticize it too much. But we need to step back. And I remember when I first started biodynamic farming in a market garden, I looked at the periphery beyond the fence line, and this is on sandstone, so it's not the richest soil in the world. And there was this profuse growth of really, these plants working in a community, very lush, tall growth, pampas grass and many other green things growing on this bedrock of sandstone, essentially, with, of course, some clay. And then here we were trying to eke out an existence where we were ploughing up the soil, oxidizing the soil, sending off CO2 to the atmosphere in order just to make it powdery to plant our seed. And it just instinctively, I didn't know why, but I just somehow knew it was wrong. I mean, I felt for the earthworms being chomped up as the rotary hoe went through, which of course you just don't do, and these days. And and the other thing I felt, because, people don't realize, why do you pay more money for organic food? Well, I was weeding carrots by hand, with my nose to the ground, almost in a kind of meditative state, day in, day out. And the earth, you become one with the earth. And you kind of go into a reverie because you're just doing it hour after hour in the hot sun. And I just felt that, particularly in Australia, but probably, across the world, why do we expose the soil to the hot, searing sun, which takes away the water, oxidizes the carbon, and basically is quite inhospitable to the microbes we need? And that kind of set me on a journey where I started to think, well, no, we need to mulch at least, and that's sometimes impractical. I remember none of this was kind of acknowledged by, the farmer I was working under and so on. And I remember I went to Melbourne and went to another farm there. And fortunately, the guy came across, and instead of just weeding, and of course you should weed and throw it in the compost if you can, but what he did, he just weeded and left it on the ground to protect it. So we need this, in some way or other, we need this buffer, be it mulch, be it residue, whatever, to protect that soil from which we're growing things. It's my clear conviction now that we can make a huge difference by covering the soil with cover crop, living plants. And I'll speak to three significant points, because essentially my focus for the last 18 years, how do we use nature-based solutions or soilutions to cool the planet? That's been a key focus for 18 years. And the first point is, look, the estimates are that we only have 60 years of soil left because we're losing it due to erosion, be it wind or water erosion. What do cover crops do? It stops the erosion, full stop. It's estimated between, I've heard low estimates of 25 billion tonnes or up to 80 billion tonnes of soil is lost every year on the planet. Irrecoverable.
Mm.
The second point is that when you have plant covering, like a green garment covering the soil, protecting the soil like nature does, wherever you look, you increase evapotranspiration. When we work out at the gym, or exercising, the mechanism to cool ourselves is sweating. And there's that evaporation, the amount of energy required to shift the water on our skin to a gas is equivalent to 596 calories per mil of water. It's a lot of energy. So that's a cooling mechanism. Plants are the cooling mechanism of the planet. And I include trees, of course. So what does it mean to, what does it mean? How can we get a measure of that? If we increase the transpiration of the planet, evapotranspiration of the planet, by a mere 5 degrees, that would stabilize the climate. So that's number two. The third point, and this is profound, and it really hit me, there is a thermodynamic law which says that the amount of heat that's re-radiated back to the atmosphere and is then captured by greenhouse gases is equal to the surface temperature, whatever that is, to the fourth power. To the fourth power. So if you have a living cover crop, you will get, in one illustration, a temperature of 19.5 degrees Celsius. If you slash that as a cover crop, you go up to 23.5 degrees. If you have bare ground, and these are beds side by side, it goes to 43.8 degrees centigrade to the fourth power. That's how much heat is being radiated back to the atmosphere and then trapped by greenhouse gases. So those three things alone give credence to the conviction that we can make a huge difference this decade if we cover the ground. Now, my conviction is that we do need to do this in every context. Now, obviously, we and others listening to this program are in the kind of, the regenerative stream. But my contention is that even in chemical farming, in other words, every farming enterprise, be it horticulture, viticulture, silvopasture, agroforestry, whatever agriculture enterprise, and even conventional farming, if you keep all the ground covered all of the time, you've got climate change covered. I mean, we could end the program. We could end the program now, really. But in other words, it's a grassroots movement. But although you said at the beginning, we're looking at the surface. See, what plants do, they really tie together what's happening above the ground and what's happening below the ground. And one of the principles of regenerative farming is to have living roots. They do many, many things. But let's just look at a few more stats. If you have cover crop, you actually increase production. You don't decrease production. You increase the soil carbon by 7.8% compared to the same field not covered. But you increase the nitrogen by 13.8%. In other words, you're creating a context to hold onto nutrients. You're stopping not only loss of water, but also key nutrients like nitrogen and particularly carbon. So one can see in that illustration how important it is. Now, let's take the example of, Colin Sy's work, who's, developed pasture cropping, where, his back was to the wall. He'd been through a drought. He said this was not low input farming. This was no input farming. There was some native grass lying on the ground. It was, at the end of its cycle. And he planted the cereal crop into it directly and got a bumper crop. And year on year, there's about 2,000, hopefully more farmers now doing that. And they're increasing their yields. They're conserving their soil moisture. They're increasing their carbon sequestration, and they're increasing productivity, not decreasing productivity. Another example, because we're talking about, broad acre, but let's talk about monoculture. Monoculture, in a sense, simplifies. We try to simplify nature all the time. It goes against the complexity of nature, as I said at the beginning. And I will be hopefully involved in a trial in Crete, or Greece at least, where we will compare the monoculture of olive groves, which is like everywhere in the Mediterranean, everywhere you go, and then see what happens if we grow a fast-growing crop like kanaf or other plants or multi-story plants or herbs, or, have beekeeping, other activities that generate revenue, and actually evaluate not only the economic outcomes, but the improved biodiversity, bringing improved environmental outcomes. We know that to measure the health of a healthy ecosystem, it's always based on biodiversity, whether it's biodiversity of your microbes in the soil, or your biodiversity of your pasture, or your biodiversity of species, shrubs and trees and plants and herbs and so on. So clearly that is the model. Now, is there evidence to back that up? Yes, there is. There was a study I read recently in Brazil where they are bringing palm oil. Now, the palm oil industry can be quite destructive. It's very monoculture. And unfortunately, the practice of burning the fronds that are cut back and so on, hopefully that's changing, adds a lot to greenhouse gases. Now, in Brazil, they grew other crops in amongst the palms, and for every tree, they increase the amount of palm oil produced. So it doesn't decrease productivity. So I'm hoping, with a bit of luck, to do a trial in Malaysia, where we're wanting to we are in the process of contacting the palm oil industry and hopefully get a pilot project and plant kanaf, fast-growing plant. And we use that kanaf to generate hydrogen using microbes, and then we take the residual fiber to produce carbon-negative homes. So we're creating a circular economy. We don't actually decrease productivity, we increase productivity. So it's not without skill and learning. To mimic nature, we have to become wise and observant and change our practice. But, you need different machinery or different practices, or which particular, it's about species selection. A great example which confirmed this beyond doubt to me was a wonderful biodynamic farmer in the Margaret River of Western Australia. And he did kind of like farmers do, innovative farmers do. They try something. They don't know, they just try and see what nature gives back or shows us. And he was growing cabbages on a slope, right? So with a slope, if you're gonna have bare soil, you're gonna get erosion, right? Every time you irrigate or you get a rain event or the wind blows, you're gonna get erosion. So what he did was he got a subterranean clover, and with cabbage and the like, you transplant, you don't grow from seed. So you don't have to prepare the soil in this really fine powdery soil. So he just transplanted into the clover field or cover crop. Of course, clover's drawing down nitrogen. Then he had the next paddock, section, exactly the same slope, same soil, just neighbouring, and he was bare soil, and he transplanted the cabbages. And unfortunately, being a farmer, he's not measuring things. He's producing good quality food. I said, what was the difference in production? He said, I don't know, I just took it to market. But you could see for the photographs that the cabbages were bigger where the cover crop was. So you can get with real precision in your selection, you can bring about biodiversity in your cover crops, and you can even have succession, so you don't have to keep replanting the cover crop. So you can get a winter clover and a summer clover, and they just die off, and the other one comes back with the seed bank. So it's not like necessarily labor intensive. You do need special, planting. There are seed drills, etc., to break through that cover. I'm particularly interested in plants which are prostrate creepers, which are low-lying, very low nutrient demand, but cover the ground. And one of my favorites is Commelina sinai. It's similar to what you're not allowed to call now wandering Jew, but it was the early explorers were introduced to it by the indigenous people. They call it now scurvy weed. It's actually edible, and it's got high vitamin C. But I remember learning about this from a wonderful biodynamic elder who's since passed. John Priestley, and we were doing a farm field day in his orchard, and he really excitedly got down under the orchard and combed away the Commelina and said, "Look at this soil. It was this beautiful chocolate fluffy soil you could eat. Perhaps we should. I'm sure we should." But it was just great. And he said, by covering the ground with the Commelina this is in the drip line and underneath the mandarin tree or citrus tree, reduced his irrigation by 75%.
Wow.
Now, these plants are really, really adapted because they stop you naturally find them on the edge of forests or in forest floors, and they will cover the ground where you've got your leaflet. It'll grow in that sort of environment and creep along. And I remember there's a group farming the desert in Egypt called Sekem, and the viewers might want to look it up, Sekem. They're farming the desert. And I proposed to them, I said, look, I think the Commelina would do really well. And of course, the botanist looked at it and said, oh, look, this is too dry, the conditions. Well, I said, fair enough. Anyhow, I was walking along, as I do, and I'm always picking up a plant and I try and plant them somewhere else, little transplants. I'm always got my fingers in the soil, or, always being with plants. And I remember seeing on a concrete path, how the concrete's got those divisions so it can crack open, expand and contract. There was a Commelina growing in that crack on the concrete. Now, you can't tell me that that's not hot, right? Now, what it did, it not only had the capacity to reduce evaporation, how you can curl your tongue. I won't do that because it's quite rude, but you know how you can curl your tongue? The leaf actually curled to even hold on that water, to conserve the water. What a wonderful plant. So, and it grows like crazy. Whenever I see it, I pick it, put it in my pocket, and I plant it wherever I can when I'm growing vegetables. And I'm just growing on the verge because I'm currently living in an apartment. I'm not near a place where I can grow, except I will be joining the community garden soon. But I just need to have my hands in the soil. And that's just one example. The other beautiful example is when you've got a drought and you've got no pasture left, you'll see purslane, otherwise known as pigweed. Purslane in Mediterranean diet it's the highest concentration of omega-3 on any herb on the planet, not seed, but plant herb. It's very high in omega-3, of precursor vitamin A, even full complement of amino acids. And when cows eat that as a last resort, their coats shine up. They're actually quite healthy. And that's a very low feed, it doesn't take a lot of nutrient out of the soil, and it's a succulent, so it survives in dry conditions. So we need to explore the library of these plants which cover the ground, which is harsh, with its harsh conditions. And currently, most agricultural land is harsh because it's degraded land. So although we're looking at... sorry, go on. You're going to say something?
No. I'll finish it. Yeah.
Yeah. So the key to carbon sequestration is how deep your roots go below the ground. So even when you're not only trying to get diversity above the ground, covering the ground with cover crops and your cash crops, but you need to look at the root structure of your cover crop and your cash crop. And you want to find, like in nature, complementary plants which can be neighbours. You want all of the soil covered with root networks. So some will be tap roots, some will be radiating roots, some will be conical shaped roots, and so on. You want to actually, if you can see, if you had X-ray vision and you could see into the soil, you want to see that whole soil is covered with roots, because roots create channel. They create, when they die, they shed carbon in the soil. They become points of percolation of water and nutrient exchange when they die, et cetera, et cetera. So we need to really think not only above ground, as we talked about, but what's happening below ground to create that increased biofertility, that increased nutrient cycling, but most importantly, retaining the all precious, which will become the limiting factor for feeding the growing population, that is water. So it's a water conserving strategy.
Amazing. Yeah. And I agree with every single thing that you've just said for the last however long you've been talking about cover cropping and the reasons for deep root and covering, and just the opportunity to have green leaf capturing the sun's energy and bringing that carbon sugars back into the soil and feeding the microbes. I want to, like, why do you think that, like, understand the Industrial Revolution brought about machinery and everything was about running straight lines so that way machinery could work through the paddocks. And you mentioned before as well that like new machinery or a new mindset needs to come in to help with this cover cropping and pasture growing. Do you think that that is something that people are going to embrace quickly, or it's going to take a lot of education? Because I've seen what Colin Seiss has been doing for over a decade. And I see what you've just spoken about. And I think, wow, this makes so much sense. You mentioned about companion planting or plants that help each other. This one takes nitrogen, this one puts nitrogen. But there's always been this mentality of like, you have to have monoculture because you don't want the plants competing with each other. Again, another human kind of devised thought. So how far are we from people just getting this and going, right, let's just make everything green again?
Yeah, look, I'll answer that question in this way. I start off by saying we need to be learning from nature, and the peoples of the earth that have the closest connection to nature, that is the indigenous people, they connect strongly with nature. And the North American Indians, they use the Three Sisters principle. So they grew corn. Then they used climbing beans because the beans could use the corn stalks to grow. And then they covered the ground or shaded the ground like umbrellas with squash. So they had the three companion plants working together. So indigenous cultures instinctively, when they farm, copy nature. They understand these communities, these relationships. Look, it's a hard ask to shift from monoculture and then, machinery-based and chemical-based farming to restorative farming or regenerative farming. And sometimes you need to transition slowly until you become more adept at applying these processes or principles. So one of the things you could do if you've got garden beds in a horticultural context, you've got your cover crop. Now, normally a cover crop, or should I say a green manure crop. You'll grow a green manure crop, usually of ideally 30 different species, hairy vetch, legumes, cereal crops to give you more sugars in the soil, etc. It's about diversity. And then you'll turn that in to make those nutrients available for the cash crop to follow in the fallow period. I would like to do an experiment actually comparing green manuring where you turn it in to green manuring by just slashing or allowing it to go towards the end of its cycle and then planting on top of that, as in cover cropping. So what you can do is, instead of just turning it in, because to me disturbance of the soil is problematic because you're going to oxidize that soil where that precious carbon is stored. What you can do, you can actually use a rotary hoe, and although I condemn rotary hoes, if you just set the rotary hoe depth to just below the surface, you can cut that cover crop or that green manure crop, and you scatter it with soil, which will then help break down that, and you can plant into that quite easily. So you haven't got a growth of the plant. So on top of your bed, you run a rotary hoe, and there's other more refined like key line and so on, or soil key, I think it's called, where you just turn over that little bit of topsoil without destroying the structure below, and you've got all that green and nutrients lying on the ground, and cover with a bit of dirt with the microbes to break it down and plant directly into that. So that's a transition. But there are, I think, probably to my knowledge, no-till farming is taking on most in the States. I think it's something like 20%, but I could be wrong. But it's a high uptake. And some of those practitioners using no-till are using no-kill as well, meaning they keep the cover crop on the ground, and you either use roller crimpers to just crimp it down with a roller, or they use some other machinery to deal with it, so it's amenable to planting, either transplanting or seeding. But you need specialized equipment. So there is a learning curve there. And I suggest the best way to do it, like the farmer in Western Australia, you start with a patch, observe, and then you keep building a knowledge base. You don't necessarily go cold turkey overnight, because that could be problematic. There's a number of things you have to think about. Like you've got more moisture. Will that attract more fungus? Will that attract more slugs, et cetera, et cetera? So you need to know how to combat those potential problems. So, look, I think, you look at gardening shows and you see the soil being turned all the time. You look at organic farms and you see the soil exposed all the time. Because of the gravity of the situation with climate change, and this is the critical decade, we've got to turn the tide now, right? So because of what I said, those three things that happen when you have cover crop, if that can get through by whatever means, podcasts, documentaries, which I'm hoping to make, books people write, people discussing, people sharing, the press, social media, whatever platforms there are, that message hopefully will bring the change. But ultimately it comes down, for a farmer, it comes down to economics. And if you demonstrate, which I hope to do, as others have done and will do, that you actually increase productivity by increasing biodiversity, not just in your microbes in the soil, but above ground as well, that you actually get improved outcomes. So if you're in the business, the profession of farming, and you can demonstrate without doubt that you're improving economic outcomes, you're building natural capital of soil and water reserves, you're producing healthier food with increased density, you're producing pastures which increase palatability and diversity, so that the cow goes to like a salad smorgasbord. They can choose the particular herbs or forbs they need. So it'll come through, because that's what nature does. And we've gone against nature, and now we have to be consciously aware, how do we repair nature by mimicking nature and understanding the economy of nature. So it's not an easy task, but the necessity demands change. And I think we need to incentivize. Yeah. I think one of the keys is, I'm not totally a believer in science, in other words, getting evidence-based change of practice, informed change of practice. But science can be helpful. If you can produce scientific articles to demonstrate benefits, then that filters through, hopefully, into practice. Not always, but it's one of the channels. But, because I'm so convinced it's important, whenever I plant now a garden anywhere, I've got commelina growing. And it's not a problem. It's quite, it's easy to move, and you just plant your plant, or you put your seeds in there. It sits so close to the ground, it's not going to stop your seeds coming up. It is a big ask to suddenly change, but you've got a few options, and like the shallow rotary hoe I spoke of and so on. But I think we just need to understand there's that beautiful structure that's been built by the microbes, the fungi, etc. Why disturb it?
And I think a lot of the years research has gone into more which chemicals are doing better, what inputs need to go in at what ratios. And so there is this kind of gap in the research, or the funding to the research, to look at more the natural ways of growing. You cover a lot of ground lately, and I want to take a quick break so our soil listeners can hear a little quick ad, and we'll be right back soon. So stay with us. Hello, soil lovers. I hope you're enjoying today's guest and this podcast, but I wanted to just let you know that when you get excited about soil, just as you're hearing about our guests, then you will want to check out the Soil Learning Centre. The Soil Learning Centre is a hub that we put together and digitalized all the content over the years that were originally on DVD into this online learning experience. So if any of our guests or any of the topics that we speak about during the podcast whet your appetite, and you want to get your hands dirtier and dig deeper and get educated around different things around soil, whether it be biodynamics, permaculture, whether it be using a microscope, or whether it just be hanging out with other like-minded educators, mentors, and facilitators, then the Soil Learning Centre is a place for you to hang out and dig deeper. That's the soillearningcentre.com. We have lots of different programs, courses, and even a membership. So if you want to belong to a community of other soil lovers, then that's the place to hang out. Well, until we meet again, enjoy the rest of this podcast. Back to the program. Welcome back, soil lovers. You're hanging out with Regenerative and Christos. We are talking about cover cropping and everything got to do with nurturing the soil and keeping it protected, keeping the moisture there. Christos, you made a great point just before the break about the nutritional value and mainly the palatability or the taste of food and how that's changed. How are you seeing that cover cropping and soil health is changing the way that even, say, chefs are having conversations with growers, or the consumer is buying produce? Do you think people are learning that the taste has been missing and now are leaning to that, or have people just accepted that most things taste like nothing these days?
Yeah, the most comprehensive answer is yes and no. But yes, there are a few poster people. You can't say poster boys or girls, poster people. One of the great advocates is Jamie Oliver. He was approached by the British Soil Association to really talk about growing food organically and how that enhances taste and that improves your cooking. I, where possible, though don't get much of a response, will write to celebrity chefs about the importance of how we grow food for climate change and nutrition and health of the soil, the plants, the animals, and people, and I don't get responses. So it's still problematic. I mean, it always amazed me. I remember going to one of the best restaurants in Sydney, and being the advocate I am, I asked the waiter. I said, "Does your restaurant ever use organic food?" And we said, "Well, it's very hard to get, and it's very hard to keep the same." Recipes or, dishes and so on. So in other words, no. And this is the best restaurant, right? What we do is we take food that's, it's fresh and it looks okay, and we have to improve the flavor by adding things to it. Now, I'm not against that, but the basis is we start with really tasty food. And I remember a situation where, look, when I was young, I was very passionate about what I was doing, very passionate. And I remember going to a family lunch at a wonderful restaurant, and I, in my fiery tempered manner, this is the temper of youth, you see, I'm much more chilled out now. But I remember, we're having this beautiful lunch, and the end came this dessert with strawberries. And I said, how can you eat that poison? Strawberry is probably one of the most, besides rice, one of the most poison. How can you eat that poison? And stormed off, now, afterwards, in quiet reflection, I thought, no, that's not the way you're going to convince people about having good food. So what I did instinctively, I realized if you make the best possible compost and put that in the ground, you're going to get the best possible tasting food. And we were taking over a farm which had been destroyed by chemical farming over years and years and years. And it was literally like the soil structure of that bad. It was literally like cement, right? It was a clay soil. And you had to actually get a pick to break it up, right? So I picked the right spot for the compost. We had this beautiful flame tree, those beautiful heart-shaped leaves, and I got the golden leaves and put them in. And we had a donkey, we had cow, we had, it's all about diversity of your inputs. And almost instinctively, it's probably the best compost I've ever made, and I was just a beginner, but I instinctively got it, and it was just the most sweetest smelling, compost. I literally had to restrain myself from eating it. I'm kind of joking there, but anyhow, so I lovingly took this compost and I dig a hole. Now, I wouldn't do this now, but that's what I did at the time. So I dig a hole and I put the compost 100% straight in. You probably wouldn't do that, but it was such were the conditions, you couldn't do much more. And then I took these little cabbages out of the nursery and planted the transplants, and I watched it grow and grow and grow and grow. So you learn patience watching plants grow. I know in this time we have to get information across quickly, but I'm just going to chill out and watch it grow and grow and grow. And then I took this, harvested the cabbage, and then I took it and I steamed it, and I knew the right time when it goes to that peak spring green, that's when it's ready. I don't think I even put oil on it. And I served it to my brothers, and they ate it and their jaws dropped and they said, "What's this?" And I said, "It's a cabbage." So we need, we have problems with getting children to eat vegetables. And once their taste buds have been contaminated with artificial flavors and macas and so on, it's hard to allow the instinctive taste to guide them into what's good food.
Yeah.
If we have a good carrot you've just pulled out of the ground, or a pea that's, just in the pod you've just picked off, or a tomato, whatever, and it's grown with that kind of love and nature-based principles, that you don't have to take them to the candy shop. You don't have to take them to Macca's. They will love vegetables because they just taste so damn good. So unfortunately, in the culture, I mean, all the time, I'm one of these people. I watch. I'm a bit of a food. I'm a bit of a food junkie. I watch all these cooking shows out of interest. I'm not a great cook, but I'm very good. I'm a master fermenter. I ferment foods. It's the same principles of using microbes to improve the nutrient availability as you do in the soil. But I'm just curious about what they do. And very few times do they talk about how the food's grown, except for people like Jamie Oliver and other people. I mean, Costa Giardias in the Gardening Australia, they are now bringing in guest speakers, and they'll cook something on the spot, that they've taken from their garden. So it's kind of coming in, and it's not threatening. It's not saying don't have toxins, don't have, conventionally grown food. It's saying here's food grown naturally, tastes good, let's cook it up. So I think that this shifts perhaps too slow, but we know now that, some people said that an orange before the Second World War, you'd need 8 oranges now to have the equivalent nutritional value of 1 orange before the World War. So I'm not sure exactly if that's true, but we know that taste and particularly nutrient density has decreased. Just on that point, it's a little bit away from cover crops, but the power of microbes. I've been doing work in China with a professor of microbiology over 8 years, and visited China 7 times. And in our research, we found that when we just add microbes, it's still organic system. So it was in hothouses. The soil was either fertilized with compost and our 500 microbes called the biodynamic soil activator. And we found that the nutrient density went up by 30%. The water requirements went down by 50%. The keeping quality lasted a lot longer because we waste a lot of food. The flavor was enhanced. And interestingly, because the soil was healthy, because we had certain microbes that fight against disease-causing microbes and fungi, we virtually had no plant disease or pest attacks, whereas the neighboring hothouse, which these are large hothouses, even though it's grown on compost, were attacked. So it's quite evident that when we use diversity, be it biodiversity of microbes, biodiversity of plants, biodiversity of mixed farming, including, chooks and sheep and llamas and cattle and camels or whatever, that we get. I'm not saying you have to do that, but, the point is it's about biodiversity, like nature, So I hope that answers the question.
Yeah, no, absolutely. And I think you make a good point there as well, is because I feel like in Australia, I see this a lot more, is that people identify as the type of farmer they are. They're a sheep farmer or they're a corn farmer. And I think changing that dialogue to say that you're a biology farmer or you're farming the soil changes. Yeah. It doesn't matter what you do above. I see in America, a lot more people have like mixed enterprises on their land, and there's lots of different enterprises working, and Joel Salatin's been a big advocator of mixed enterprises and stacking them on your farm. But I feel like here in Australia we still have a gap around that. I'm just a corn or a bean farmer, or maybe two species.
That's part of that that's part of that culture of monoculture. I would call myself a farm ecologist, a farm ecologist. Yeah, that's a joke.
Yeah,
anyhow,
yeah.
But
I like that on words though, because people get it. I like even there's like we change the lexicon a little bit, and people can start identifying a bit different. That you're a land steward or you're a soil cultivator. You're here to protect the soil that you have stewardship on. Even the fact of owning land is a bit of a weird concept as well, because we really own it, or is it in our best interest to do the best thing for future generations? Because sense of ownership is, well, it's my land, I'll do whatever I want. But it's not really your land because it's going to get passed on eventually. And so is there a duty of care to do the right thing from the greater good?
I think we're sort of trapped in a time warp back in Newtonian physics. We've treated for a long time the soil as a machine, and we've got past the mechanics of soil. We're now talking more about the biology of soil. I think a level above that is the life of the soil and the ecology and the ecology of farming enterprises. So it's kind of shifting away from that Newtonian type physics approach to a more elaborate, complex understanding and relationships. But I want to contrast two things in the paradigm that exists between the paddock between our ears, so to speak. And I remember going to a lecture of a well-renowned soil scientist who was speaking about nitrogen. And there's this kind of dilemma that you get with reductionistic science. And there was an imperative set by the EPA, Environmental Protection Agency of America, saying, look, we need to grow more food, so we put nitrogen fertilizers on. But the downside is we get dead zones, we get mass fish death, we get loss of aquatic life, we get nitrates, which can cause bladder cancers, et cetera, et cetera. You've got to use nitrogen more efficiently. And this is a very erudite lecture. And he spoke about looking at where you need to pulse, precision agriculture, where you need to see in the growth cycle plant, when do you need more nitrogen? So we give more nitrogen then. Then how do we find plants which are more efficient with nitrogen? So we splice in some of those attributes, et cetera, et cetera. And at the end, the question and answer, I said, thank you so much for that in-depth presentation. I mean, in a certain sense, I have respect for the degree of detailed knowledge of reductionism, because it does bring insights, but we don't know how to put it back together again. I said, I understand the dilemma. You've got to reduce your nitrogen use because of the environmental and health impacts, but we've got to produce more food. But 78% of the atmosphere is nitrogen. And in Brazil, they did a study where they grew corn alongside legumes, and they got equivalent or increased yields. And so why do we need to put externally nitrogen inputs? And he said, well, I don't know about that. And he said, besides, there's not a transfer of nitrogen across. Well, we now know that particularly if you've got a heavily, a soil which is high in fungal populations, they do have distribution networks where there's a communication going on, and the corn says, I'll give you some sugar if you give me some nitrogen. That's what happens. It's like a stock exchange floor or a trading house. It happens. So, and he kind of like scratched his head a bit and kind of, they went on to the next question. But I reflected later and I thought, well, no, what's happening here is that his research, you mentioned research before, and funding, he's funded by the chemical companies to find more efficient ways to use the nitrogen fertilizer. It's probably one of the most destructive things we could do to the soil and the atmosphere.
Yep.
And then I thought, what's happening is we're using reductionism to solve a problem that came from reductionistic science. We need to find holistic thinking and approaches and holistic science to match the holism of nature. And until we take that journey in our agricultural science or a land management or environmental science, we're kind of really behind the eight ball and we're stuck back in the time warp of Newtonian thinking. So it is problematic, and I think we're running out of time, but it's a challenge. But what's I think is exciting is because of the desperate nature, without getting overwhelmed, because of the desperate nature of nature really breaking apart, that we have to come to solutions. It amazes me, this is getting away from cover crops, but actually it's related. One of the beautiful things about cover crops is you don't need to use herbicides because it suppresses weeds. In fact, you don't need to use pesticides, or you need to use them less, because you created an ecosystem where the beneficial insects, the predatory insects, will eat the herbivorous insects, right? Wonderful. So cover crops has got it covered. I think that we are at the crossroads, and we really should see this as a challenge to develop ingenuity and be brave to try the new and go into the unknown step by step towards a regenerative future.
Agreed. Yeah, agreed. And I think there are so many evidences now of seeing that biodiversity come back to a farm where one pest problem is solved by the next pest or bug or creature that gets invited onto the farm because the biodiversity is there, and if we allow that to unfold long enough, it's a nice holistic cycle of life where each predator takes care of each other and eats each other and creates a nice, ecosystem that solves a lot of the problems. It's when we start taking, each piece of that puzzle out that we start breaking the structure, and we need to allow that the land and the biodiversity to heal. And I think that's what a great point you make, where one of the things I saw not long ago was an article of talking about a protected land that was part of a what they call it when they conservation park. And then down the road, there was a regenerative farmer, and the regenerative farmer had attracted more unseen species than the protected park, which is its whole purpose was to be locked up and put a fence around it and conservate animals and bring back the life and no one disturb it. And yet a regenerative farmer down the road was doing a better job at attracting the wildlife and the species that this whole park was. One's begging for profits to sell produce that's well nutrient, and the other's getting millions of dollars of funding from government and EPAs to protect it, and it's like, where does the regenerative farmer get rewarded for that same effort? And I see that with biodiversity credits and natural capital and carbon as well.
One way I think of telling the story is nature's so interconnected. It's like everything is attached to a string. And if you pull that string, everything would come along with it. So when you intercede in a natural ecosystem, if you bring in, say, fertilizer, there's a beautiful quote by an extraordinary man. It's a doco that's worth seeing. It's called A Sense of Humus, and you have to dig it up. It was made by the Canadian Film Board. A Sense of Humus, and unfortunately, it's out of circulation. But this guy was a PhD biochemist. And what he said was, when you take out the fertilizer bag, you have to go back into the shed to get the pesticide can out. When we interfere with the natural processes of nature, what happens is you change the health of the soil, you change the nutrition of the plant's weakened, it puts out a different wavelength where the compound eye of the insect sees this frequency and says, oh, this is a weak plant, I've got to go and attack it, because I've got to take it out before it reproduces. That's one interpretation. There are others. But so in other words, when we intercede with an input which is against this integrated whole, we can enhance natural system functioning. But when we intercede and touch a level to just have one solitary aim to produce more food, which ultimately you get diminishing returns, we interfere with all this, balanced ecosystems we're talking about. So it's a false economy, it's expensive, and we're killing the structure, we're killing the biodiversity. Now, I'll finish on this. We've lost 70% of our insects. And a lot of that's due to habitat change, but a lot of it's due to pesticides, obviously, because it's not selective. Insects are the glue of nature, but they're the glue of nature above ground. The glue of nature below ground is microorganisms, which secrete biofilms and glomalin, which creates soil particles to stick together. It's a soil glue. So with our chemical interventions and our mechanical interventions with the plough, we're destroying the glue of nature below ground, and we're creating unhealthy soil, creating pest pressure to require pesticides, which are killing the glue of nature above ground. It's just an abomination. And out of necessity, just sheer economics, people are going towards biological farming just because the fertilizers cost too much. And they're adopting, how do we use our fertilizer more efficiently? I think some farmers need to transition slowly. Oh, I can add, microbials. Oh, I don't need to use so much fertilizer. Hey, maybe I can use less. Hey, maybe I don't need to use any. So there's slow transitions, and it's not an easy task, but the demands of the time mean we have to be courageous, and we have to go forward with science. We have to educate the consumer. We have to share knowledge with farmers. We have to mentor farmers, and be open to those people who want us to create change in their farm ecology. Yeah.
Absolutely. I think you make a great point, and soil lovers listening to this, whether you're driving in a tractor or in a car or just sitting there reflecting, listening, it is a slow transition. And I think we live in a world where everything is instant gratification, and this regenerative transformation is a slow one. And I know it's hard sometimes hearing these techniques and thinking, oh, I don't want to damage the soil and I don't want to till. But like you said as well, Christos, maybe shallow tilling is good, or the right type of tilling at the right time, because you know what your North Star is and you know where you want to get your farm, but there's stepping stones to get there. So it's not about rushing out and selling the tiller and changing your tractors and your devices. It's about doing one small step at a time. So on that note, have a reflection and think about, like, what is one small thing you can work on in the next month, in the next quarter, in the next 6 months that can progress you closer to that soil health, regenerative mindset and farming enterprise. Christos, before you head off, we have to ask our signature question, because otherwise it wouldn't be Secrets of the Soil. But you are now about to become the voice of the soil for the second time, because this is your second time on our show. But now with your cover crop hat on, and you were to become the voice of the soil, what would you say to the listeners and the humans out on the planet listening to this right now? And you've just put a hat on if you're watching the video version. So here is Christos becoming the voice of the soil from a cover crop point of view.
I am the soil. I'm the voice of the soil. I am thirsty. I have lost my structure. Protect me. Cover me with a beautiful green garment stop cutting into my belly with plows and surgical knives. Let me be buffered and protected from the hot suns and the driving rains and the searing heat. Keep all the ground covered all the time, and I, you, we, and the planet will thrive.
Absolutely. Beautifully said. And it is definitely a cover, blanket, comfort, and especially with the winter weather we have now, that's a great analogy to just rug up with a blanket, and we need to do the same with our soils and protect it. Christos, thank you so much for chatting about soil. I think we could chat for hours and hours and hours, but a good point. You did most of the speaking, which I love because I also learned a lot. And you were kind of reading my mind at many points. I was thinking, what am I going to ask? And you would just take the conversation right there. So there was definitely some synergy happening with what I was thinking and what you were sharing. So definitely on the same page. So thank you so much for coming along.
Thanks for the invitation. I love sharing this knowledge, and you're a great interviewer. And I apologize if I talk too much. I'm Greek. We talk too much.
That's all right. Me too. I move my hands on. I have to be really conscious about it because I'm normally like tapping the microphone all the time. So I've got to lock them in my pocket. So excellent. Well, soil lovers, there you go. Get outside, get your hands dirty, and start thinking about how you can protect your soil. If there's ground that you can see that's brown, then maybe think about what you can plant there, put some seeds and cover it up and protect it and create that nice armor of protection from hydration, the sun, and everything, above the ground. So on that note, enjoy the rest of your day, and I'll speak to you next time during Secrets of the Soil. Well, soil lovers, that's enough secrets for one episode. I really hope that you enjoyed all the secrets shared during this conversation. But hey, let's not keep it a secret. Please share this podcast around and make sure that you like it and leave us a review, because that really helps spread the secrets of the soil. Until next time, remember, get outside, get your hands dirty, and keep digging deeper into your soils.